I'm waiting to have the chime. So all right, there's the chime. All right, you guys, BC Calc students, one thing that I want to talk about before I do this next part of the lesson with you is that there's a little known fact about parabolas that I want you to know about as we approach this next problem. It can make things a little easier to calculate areas when you know you have a parabola. Check this out. I've drawn the parabola y equals x squared here, and there it is. Okay, and what the rule is if you draw a rectangle starting from the vertex and going to some point on the curve, this rectangle here, right? There's a rectangle here. This rectangle would, in this case, let's see, what area would it be? Its base is 2 and the height is 4. So that overall area would be 8, okay? Well, there's a little known fact about parabolas. If you start at the vertex and you go to a point on the curve and draw a rectangle around there, the area underneath the curve will be exactly 1/3 of that rectangle, of that big rectangle, okay? So if you do a Riemann sum with one rectangle and a corner of your rectangle is at the vertex and the other corner is on the curve, and you evaluate the height of that rectangle at that point, that area underneath there will be exactly 1/3 of the Riemann sum. It will be 1/3 of that rectangle. And so you guys, let's check this out. There's a function on here. Usually this is down. You'll see this keyboard show the keypad thing. Click on that, and you'll notice there are functions in here, and they have trig and stats and distributions and miscellaneous. And here we have this one, an integral. And so if I integrate this curve going from 0 to 2 of x squared dx, whoops, I want the dx to be there. If I do that, you'll notice I get 2 2/3. And check that out. That is indeed the area that you would get if you did 8 divided by 3, the area of the rectangle, 8/3, 2 2/3. And so we're going to use that on this next piece here, okay? So here we have a continuous function f graphed below, and this is a very common BC Calc test question you guys can expect to see. It consists of a line segment, a parabolic arc, and a quarter circle, okay? And they've given you these equations. I'm giving you these equations here. Generally, they won't do that on the test itself. They'll expect you to know those or know the rules of geometry so that you don't actually have to calculate things. You can avoid a lot of work on this problem if you know your rules from geometry, your area formulas for geometry. You should know the area of a circle, and then this is a quarter of a circle. You should know the area of a triangle, and this is, you know, that's a triangle right there. And then what I just showed you, this funny area under here, you'll have to break into 2 pieces. You'll have to, this area from here to here, you'll have to break this into a rectangle whose area is 4. And then you'll use the trick that I just showed you to calculate that area there. You could integrate this function. You could integrate it and go from 0 to 1 also. You have that option. I just want you to be able to quickly use that for parabolas. This is indeed the vertex of the parabola. And this parabola, if you go over to 1, would indeed hit through here. And so what we're saying is this little shaded area right there is just 1/3 of the area of this rectangle. In this case, it's a square whose area is 1. So that area right there is 1/3. Okay. So anyhow, it says write an expression using definite integrals for the entire shaded area and then evaluate the area in exact terms. Hint, you may use your geometry formulas if necessary. And so I'm going to advocate that you do that. So what you can do to represent this first portion here, to represent this triangle here, okay, I'm nervous about doing this. Let me do this. I'm going to use an orange integral sign, okay? And then if I make a mistake, I can fix it. I would integrate from -4 to, what is that, 0 there? Gosh, yes, 0 of this function, x plus 4 dx. And you guys, notation reason, you need to multiply these two things together. If you don't have the parentheses, it's a notation error issue. Okay, and then plus All right, the next integral, let's see. Let's use blue for that one, okay? This next section of area is this area here, okay, like so. And that area is, oh, let me use a blue integral. That is equal to the integral from where I left off before, 0 to 1 of, okay, let me show you what I was talking about, x squared plus 4dx. If you write this, that's technically incorrect because only the 4 is getting multiplied by dx. This is kind of meaningless here. If you added up every value of x between 0, 1, and squared it, and there's an infinite number of them, you'd end up with infinity here. So it's very important you multiply each of those by the width of the rectangle dx. Okay, and then finally, the last section here. Gosh, I don't know if these colors match the PDF or not. I don't think they do. I think I used 3 different colors on the PDF. My printer didn't print in ink. I'm sorry about that. If those of you that have a color printout there, I'm sorry. I don't think these colors match. I should have made an effort to have a match. There we are. So we're integrating that so plus the integral from 1. Let's see, 2, 3, 4, 5, 6 to 6 of this, the square root of 25 minus x minus 1 quantity squared dx. Okay, and so some of you might say, okay, wow, this is a really challenging problem. And this one you could probably work out. You do x squared over 2 plus 4x plus c, evaluated at 0, evaluated at -4, and subtract. But part of this course is recognizing what this is asking you for. And you guys, what that's asking you for is the area of this orange triangle. So you are allowed to do that. You're allowed to use your knowledge of geometry. The area of a triangle is 1/2 of the base. The base of this goes from -4 to 0. So that would be 4. And then times the height, that would be 1, 2, 3, 4. And so there's my orange area. Okay, so that is a technique of integration. I mean, that's one of our primary techniques of integration. Without having to do a bunch of algebra and symbols here, we simply recognize, gosh, that's the area of a triangle. Okay. All right, this next one, the blue one, is tricky, and that's why I'm glad I showed you the thing about parabolas. This area underneath here, this entire blue area is 1, 2, 3, 4, would be plus 4 plus, and then since this is on the vertex and this is on the curve, that little tiny area there would be 1/3 of the area of this rectangle drawn from the vertex to the point on the curve, which is just 1 times 1. And so that is the blue area. That represents the blue area. Now, some of you may cry foul and say, well, I never heard that before. They didn't teach me that in geometry. I didn't know that. So we could work it out. We can go and do that. Let's actually work that out over here, and we'll work this out in a second. Let's actually work that out. And what I'm saying is we're going to get an answer of 4 1/3. Okay. All right. But let me continue with my momentum here. All right. This one. Gosh, we don't have a way of integrating that yet. Okay. We don't have it. All right. We're going to learn how to do this kind of integral later, or you guys are going to recognize that and say, wait a minute, I recognize that as a function that would represent a quarter circle, okay, or a semicircle, and then we're evaluating at certain limits here. That's a technique of integration that you're going to be expected to apply. So what we need is the area of a circle, but a quarter of that. So that would be plus 1/4 of pi times the radius squared. Now, please be careful. The radius of this circle is not 6. It goes from 1 to 6. So that radius is actually 5. You need to be very mindful of that. This is the center here. Remember, it shifted over 1. So the center is at 1, 0. So we go over the radius 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That would cost you 11% of your points on the test if you did that. On the BC Calc test and said 6 there, you'd end up with the wrong answer. You'd lose a point for it. Okay. All right. And so here we are. What are these different areas? This looks like what? 16 halves, -8. Okay, that's weird. Why would I have written a negative there? That's really weird. I'm sorry. I'm not going to reshoot the video based on that. I don't know why I did that. Okay. That was weird. What was I thinking? Anyway, this area would be 1/2 times 4 times 4, positive 8. It's above the x. Oh, I guess I was thinking it was -4. I was going from -4 to 0, but this area here is above the x-axis, and that's why I screwed that up. That would be positive 8. Okay. And then plus 4 1/3. Okay, and then plus, this would be 25 pi over 4. Okay, and you guys, these are like terms. I know they don't feel like it, but you need to be able to add fractions. Again, on the AP Calc test, you could stop here and you'd be done. Okay, there's your answer. But in my class, I want you guys to learn to keep your fractions and everything, your skills up to date. So this would be 12 1/3 plus 25 pi over 4. And yes, I do think it's a good idea to get to do common denominators and what have you. I do think that's a good skill to keep. So this would be what, 37/3 plus 25 pi over 4. I need a common denominator. Multiply this one by 4 over 4. Multiply this one by 3 over 3. And so I end up with 4 times 37. That would be 148/12 plus 75 pi over 12. And so I don't want to use, I need this area down here. So I'm going to go up here, and this would be what? 148 plus 75 pi over 12, like so. Okay, and there I have it. Okay, good. And I hope I didn't screw up that fraction. Okay, but there you go. I think that's an important skill. Okay, all right. Now, those of you who feel like you should be using calculus, and this is a common issue, you guys, on a calculus test. A lot of you are going to, come in to take the test, and you're going to think, well, I'm in calculus, so I should use calculus on everything. And that is a false assumption. Do not assume you have to use calculus to do every calculus problem. If you understand the concept, you can simply use these tricks to evaluate this area. This would take an afternoon of work for us to do. We haven't even learned how to integrate this yet, okay? So this would take hours and hours and hours to work out if we thought of it as a bunch of symbols. But if we think of it as a series of geometric shapes, it's much more manageable. Okay, I do want to convince you that this does in fact equal 4 1/3. I want to show that what I told you earlier is consistent with what we know. An antiderivative of this function would be x cubed over 3 plus 4x plus c. And I'm going to evaluate that from 0 to 1. So I plug in a 1. I would have 1 cubed over 3, which is 1/3, plus 4 plus c, minus, plug in a 0. 0 plus 0 plus z, like so. And you guys, there it is. You end up with 4 1/3 plus c minus c. There's your answer. Okay, so this one, maybe it's easier to actually work it out this way instead of worrying about the whole trick I taught you about the rectangle and a vertex, but there you have it. Okay. All righty, number 4. Okay, same function again. Suppose this time we define a function g of x being the integral starting at -4 and going to that value of x. So notice how those match, of f of t dt. Now in this case, we have to use a different dummy variable. We can't use x here, here, and here. That's simply wouldn't make sense. You can't say we're going to change x to every value between -4 and x. That doesn't make sense, because you're changing x to be everything between -4 and x makes no sense. So you simply can't do that. We have to pick a different dummy variable here, t. But what's important that you recognize here is that this function f is a derivative of g of x. So this is a graph of f, or g prime of x. It's important you recognize that, because these match, and this is just a constant down here. It's important you recognize this function here is indeed the derivative of g of x, right? This line and so forth is the derivative of g of x. And so very important, if you see that this is a graph of the function f, but it's also the derivative of this function g, a lot of these questions get a lot simpler, okay? All right, so g of negative 2, what would that be? Well, by definition of what this function is, g of negative 2, it literally means I replace everywhere there's an x with a negative 2. So I'd have the integral from negative 4 to negative 2 of f of t dt. I don't replace the t's with a negative 2 because that was x, not t, okay? And so what this is telling me to do is to take this function and integrate it from negative 4 to negative 2. And so I integrate from negative 4 to negative 2. It basically wants that area there. That's the area that it's asking me to calculate. Well, that's simply the area of a triangle. Its base is 2. I don't want to say negative 2. Its base is 2 times 2, 1/2 of base times height, which would just be 2. So that's 2. I'm not going to put square units on here because they didn't give us any units in this problem, and so I'm just going to say it's 2. So g of 2 is simply 2. All right, what's g of negative 4? Well, by definition, g of negative 4, this is the easy part. You just do the algebra. You just copy it, right? That's the integral from negative 4 to negative 4 of f of t dt, okay? And then after I copy it, I'll worry about what that means, okay? Well, wait a minute. If you're integrating a function from negative 4 to negative 4, the rectangle thickness is 0. So even if you divide that into an infinite number of other rectangles, the overall thickness is still 0. There's no area there. So this is simply 0, okay? All right, now g prime of negative 2, that gets tricky, okay? The derivative of this function g is just f of x, okay? So by definition, those are the same thing, okay? So g prime of x is simply equal to f of x, like so. Very simple, okay? Now, we will get to problems later where this does not just have an x there, and this is not a constant here, and that's a little bit different. We'll handle that differently. That's in a few days, okay? But for now, for this problem here, we simply recognize if you integrate a function and then you take its derivative, you're going to be right back where you started. And so g prime of negative 2 is by definition f of 2. Well, what's f of 2? Well, f of 2 is this function. It told us this is the graph of f at 2. There we are. Now, unless you can estimate that graph accurate to 3 decimal places, and I doubt any of us can, you better use the actual function. So fortunately for us, they did in fact give us this function. And you guys, I'll be honest, on the actual BC Calc test, I don't know that they're going to give you that. I don't know that they're going to give you that function. You will be expected at that point in time to understand how to write the equation of a circle or a semicircle and be able to evaluate it there. Okay, I mean, that's just part of the deal, right? You've written equations of circles since you were in geometry, right? So anyhow, let's plug that in. That would be equal to the square root of 25 minus 2 minus 1 squared, like so. And that would equal the square root of 25 minus 1, or the square root of 24. And you guys, I don't want you to lose your ability to simplify these. That would be what? The square root of 4 times 6, or 2 radical 6, like so. Okay. F of 2. Oh dear, I screwed up. I apologize. This is negative 2. I've messed up my minus signs yet again, okay? F of minus 2, that's embarrassing. Nope, don't use this at all. At negative 2, it's just 2. G prime of negative 2 is f of 2, which is equal to f of, I did it again, negative 2. F of negative 2, which is just plain old 2. I apologize, okay? Looking at the clock, that's pretty bad. I've made 2 pretty significant errors already on this video, and the question is, do I reshoot the video, or do I risk having you slightly confused? I'll put a note in the assignment itself that says I made some mistakes with my minus signs in this video, and I hope you caught that before watching this video. Alrighty, let's move on. Okay, g of 1. Okay, by definition, we simply copy what we have here. That's the integral from negative 4 to 1 of f of t dt, like so, okay? So we're going to integrate from negative 4 to 1 of f of t dt. So it wants this area here, like so. It wants this entire area. Well, fortunately for us, we already evaluated those up here. We already did that, okay? The area of this, of what it asked for here is this triangle plus this little funny shape here, and we've already done this work. So I'm simply going to borrow my work that I had before. Can I get both of these on the camera at the same time? I really can't. It's 1/2 times 4 times 4 plus 4 plus 1/3 times 1 times 1. And this was equal to what? 8 plus 4 1/3. And you guys, please don't screw that up. Those are like terms. A 5th grader would not screw this up. That's 12 1/3. Okay. And I get the weirdest answer from you guys sometimes. I get the strangest looking answers, kooky looking stuff with this. Please. Those are like terms. Add them together. Okay. Last one. G prime of 1. Okay. Let's see if I can get this right this time. G prime of x is equal to f of x. Okay. So G prime of 1 equals f of 1. Okay, so here we are. This is the one that I ended up doing over here. It's just now we're doing g of 1. I'm sorry, we're doing g prime of 1, which is f of 1. Oh, but look at that. F of 1 is simply right here. You simply count that directly off the grid. 1, 2, 3, 4, 5. That simply equals 5. Okay, and there we have it. All right, you guys. I will catch you at the next segment of the video. Okay, hope I do a little better job there. That actually is a tough one. Okay, all right, see you at the next video. All right, you guys. Okay, all right. Okay, I've lost track of my ability to hang up. All right, hide that. Let's see. Okay, you guys, take care. Bye-bye.